interesting part. Let's take a closer look at the correlation coefficient, okay, the R. So the correlation coefficient, and that's it's a number that Desmos will give us once we start putting in some of these data and taking a closer look. But I just wanted to look at how the correlation coefficient fits some of these different scatter plots. Okay. So first of all, if it's a negative correlation coefficient, it means that the points are going down. So this is negative, this is negative, this is negative. The rest are, well, this is nothing, but these two are positive. Since it's negative and it shows 95, which is a pretty high number, which means that the scatter plot will be, the points will be closer together. Okay, so since it's negative and it's 95, I would say my best bet is this. I'm just going to write the letter A for R equals negative 0.95. Okay, let me zoom in a little bit. Okay, there. Let's look at another one. R equals negative 0.9. Well, this is negative, and you notice that 90% is less than 95%. So even though the points are close together, this looks like it is a negative 0.9%. This is a better fit. Oh, why did I write it there? Hold on. This is going to be B, and the R equals negative 0.9 here. Okay. Negative 0.7. This is negative, and you notice the scatter plot is a little bit more spread apart here. Okay, so that means that this is going to be the letter C for R equals negative 0.7. Okay, so just take a look at all the negative ones. This is negative 0.95. You notice the points are closer together with the line. Here, they're kind of a bit more spread apart because the correlation coefficient is at 90%. And then this one is at 70%, and you can see the points are more spread apart. For D, when R equals 0, this is telling me that there is no relationship, okay? And if you notice this one right here, it looks like there really isn't much of a relationship here. So this is going to be D. R equals 0. And let me go ahead and just write here no correlation. No relationship or no correlation is a better way to say it. Okay. All right, and then the last two that I have here are positive numbers. R equals positive 0.4, that's about 40%, and this is 80%. 80 would be this one because the points are closer to the line here. And then this one definitely, even though you can kind of see the trend going up, where here I can't tell if it's going up or down or anything. There's no correlation here. So for this, I'm going to say E for here. Here the correlation is R equals 0.4. And then here, this is going to be F. It's going to be R equals 0.8. Okay, so that's the correlation coefficient, how it works. And then use the scatter plot V, this one right here, to estimate the value of the output at x equals 2. Okay, so I'm going to focus on this scatter plot right here. And output, so output just means the y value. So we're looking for the y when x is 2. So when x is 2, let's take a closer look. My y value looks like it's at 4. So y equals 4. Okay. using scatter plot 3, I said V, this is supposed to be 5. Anyway, 3, which would result in a more valid estimate, okay? Scatter plot 3, so this one right here. When X is 4, my Y value is about, I would say about 3.9. And then for X is equal to 15, well, it's kind of hard to tell, right? Because 15 is like all the way here. It's like actually off the graph, and then you have to go all the way up. So basically what happens here is this line keeps extending, and then we're able to find 15 and then go up to the line and then find the Y value. But the thing here is I don't have an equation here to be able to predict it. So what I'm going to do is I'm going to hold off on this and then show you how to find values for Y when we actually have an equation. Okay, so I'm just going to put a little question mark here for that.